likely to get breached one way or another. It's good to have defense in depth, and your second layer is essentially useless. So I'd like to try to demonstrate this next attack, but first I'm going to talk about it. That's why I found this. I did this a year or two ago. I mean, IPv6 router advertisements, and let me just review this if you folks aren't into IPv6, which you should be. But anyway, here's the old attack, all the way back to 2011. DHCP and IP version 4, you boot up your machine, it asks for an IP address, and the router says use this one. That's the end of the transaction. But in IP version 6, you typically do it with router advertisements, which is a push process. The router sends out these router advertisement packets to every machine on the network, and every one of them has to immediately join that network. So the router makes all the clients work. And that's the root of the problem. If you send a lot of router advertisements on the network, the clients have to do a lot of work joining all those networks. The router advertisement goes to FFO2::1, which is the link local multicast to all nodes. And it contains a prefix. And so every device that receives this has to make up the second half of their address and join this network, which is not too bad, but if you send thousands of them on the network, it can be a lot of work for those devices. And Windows machines are fantastically inefficient at this, and also FreeBSD. Windows can only make 5 of these addresses per second. So if you send more than 5 router advertisements per second, it drives the CPU to 100%. If you send them fast, it builds a huge backlog, and your machine is at 100% for hours digging through them. So it's a serious denial of service vulnerability. And it has no effect on Ubuntu Linux, no effect on the Mac. It just configures the first 10 addresses or so and then ignores all the rest with no apparent damage to the machine. And that's the previous attack, Flood Router 6. Now, a month or two ago, the German group that made this came out with a revised attack, the new RA Flood. So the new RA Flood just puts more work in each router advertisement. You can advertise multiple routers with one packet. It's permitted by the protocol. So you just put 17 routes in the packet, 17 prefixes and 18 routes. So each one of these packets is like 20 or 30 of the previous ones. That makes the attack more powerful. And this one is exciting. I expected it to use up some CPU, but that's not what happens. It kills machines dead. It kills the Mac dead. It kills Windows 8 dead. Windows 7 and Server 2008 R2 have an update Microsoft finally put out after about 2 years after doing this, called the IPv6 Readiness Update, and that doesn't really protect you entirely, but it causes the machine, instead of having a huge backlog that will take hours to chew through, it just freezes completely during the attack, and when the attack stops, it recovers quickly. So it's not completely protecting it from the attack, but it's somewhat better. By the way, this one, on a wireless network, we were able to crash an iPad 3, but it wasn't too reliable, so I decided not to try to demonstrate it here. But anyway, I put up a lot of videos of these things happening, and you can get all these on my website, samsclass.info. We've made videos, and for mitigation, see, normally I do the demo and then talk about this, but this is like a rock performance where you burn instruments at the end. I'm going to destroy every machine, so I have to finish with all the PowerPoint before I attempt this. So if you want to prevent this, you can turn off IPv6. That's, of course, kind of a retro motion, but it does, of course, protect you. You can turn off router discovery, which means your machine no longer auto-configures addresses, which is going to protect you from this attack, although it will prevent you from using router advertisements. You can get a switch with RA Guard. This is the Cisco solution. Modern Cisco switches can be configured to only permit one network port to put out RAs and not take them from anywhere else, and that will help. You can also use a firewall to block the undesirable packet, a firewall to block ones that come from unauthorized addresses. And like I say, Microsoft's IPv6 Readiness Update provides some protection, but it is only available for Windows 7 and Server 2008 R2. They have not released it for any other version, but it's only about a month old. So let me attempt this demo, and if you'll bear with me, I may have to spend a minute plugging in some cables here. The switch is on. Did this thing lose its power? It's gone down.
Yeah, it just goes to sleep a little bit.
Goes to sleep.
Yeah.
It doesn't appear to be waking up. See if the power cables come out or something. Let me bring my E up. My E is up. And we need to get the projector. Where's the projector? Here's the projector. Good. Okay. So we should have a Windows 8 target here, and we do. Good. Let me get my second projector up.
Actually, that's my one to move.
That's all right. No, I'm going to put it up on the white screen on top of the other stuff. That'll work. Nah, we'll be. That's good. It's coming up. All right. And everything, they are not all connected to this network, however. Let's see. We need the Mac connected to the switch. All right. And we need, there must be a fourth cable. The VIATA is connected. The attacker is not connected. Here's the fourth cable. Okay. All right. They told me that I shouldn't add a demo on such short notice, so nobody can give me help setting up, but I did it anyway. So please bear with me. Things will be a little unprofessional here. All right. Oh, good. That's coming up. All right. So let's get this thing up. All right. Good, good. This is good. You can see Windows 8. And let's try and make it a little taller. This thing. Good. Oh, that's perfect. Okay. So this is glorious Windows 8. It doesn't need to be very professional or anything because the effect is not subtle. So let me bring up ifconfig. EN3, good. So I'm going to watch my the ifconfig of my Ethernet adapter, which is a gigabit adapter. This, by the way, is an extremely impractical attack. We had a lot of work to make it go. It's you have to have very fast network for these dramatic effects to happen. So we've got an enterprise class gigabit switch, a gigabit USB interface on this Mac. This is a 100 megabit attacker, though. The attacker doesn't really have to put out an awful lot of packets to flood the network. But it took us quite a few tries. So the Windows 8 is up. The VIATA is up. Good. This, by the way, I wanted to mention, Mr. Yang here figured this out. He told me, we ran the attack and it would work, then we tried again, it would fail, it would work. We were doing this for a week, and he said you have to have a router for the flood to kill the Windows, the Mac. And I said, why? And he couldn't explain why in a way I could understand, but it's true. I tried to ignore it because I couldn't understand it, but I tried it, and when you have a router in the network, this attack works, and when you take it out, it no longer works. I don't know why. I would appreciate it if some genius out there would help figure out why. Anyway, so but the router advertisements are not coming from the router. They're coming from this attacker on the side. Yeah? No, this is a layer 2 switch. But it does have to be an enterprise class switch. Cheap switches don't work.
You need a real IPv6 router advertising as well?
Yes. You need a second router advertising normal router advertisements, because my router is up, it's advertising normal router advertisements, it's VIATA, and that's what this 2001 DB8 stuff is. These two addresses here are automatically configured by that router, which is doing what you should do on an IPv6 network. It's just advertising one prefix so people will join that network. Now this e-attacker is going to send thousands of them. Let me just get it going here. CD, TH, okay, /flood, router 6, router 26, pardon me, ETH0. Okay, the flood is going to be going right now. And see, it's coming in. Now this machine is configuring a lot of extra addresses. And all we have to do now is wait. Let me see if I can start this. This thing here is kind of fun. This is my processes. All right. So what happens, the 8 usually goes first in about 25 seconds. $11, $12, $13, $14. Aha! The Mac just died. I don't know why my Windows 8 didn't die on command, but the Mac is dead. Now I don't have the addresses. This is ifconfig, and it's now giving me strange error messages. Oh, there went the Mac. The glorious Mac roosted at the router. So that's what I wanted to show you. Now I think. And now, if you try to go here, you see my Mac is toast. I can't bring this app up. And if by about now, if I hit this, I get nothing. This thing, if I hit the start button, I'm getting this now. If I wait another 30 seconds or so, I won't even get this. I'm not going to be able to shut the thing down. If you keep this up for another minute or so, I won't even see this. And the only thing you can do is hold down the button and give it a dead power off for both devices, as long as this goes on. So I would like, this is brand new. We only got it working reliably like 2 days ago. So I have no clue how it works, really. I understand how it burdens how he has to join a lot of networks, but I don't see any reason for them to crash. There must be a buffer overflow or something. You got a question back there? Yeah. Unplugging the network cable will stop the attack. Let me stop the attack. I'll just hit Control-C here. And when you do, your Mac is still not back to normal. you're still going to have to power it down the hard way. It'll let this machine up, though. If you get the attack going, it'll just come up and down and up and down and up and down. Now this thing can come back up. But, of course, unplugging the cable or stopping the attack will stop the damage as far as it's gone. But you see here, I'm still not able to open this app. Some things still work, but this activity monitor will not come up. And I've never seen the Mac recover from this. And by the way, here's something that I thought must be nuts too. You have to restart the Mac twice to get it back to normal. And when I did that, I thought, I'm losing my mind, this can't be true. But I realized you can't do a normal shutdown now. You can only do an abnormal shutdown. You have to do a real power up and then a proper shutdown to really get this thing back to a normal state. And by the way, other routers, you have to reboot the router pretty often. But anyway, that's what I wanted to show you. I'm glad it worked. Any more questions out there? Yeah?
How many packets a second do you need for this attack?
Each dot on my screen it looks like about 2,000 a second. And by the way, I wanted to tell you something else, since I don't know if I'm out of time yet or what. 2:34. The time man is not screaming at me. If you do this, okay, if you do this on a wired network, like I said, when we were having trouble, I tried using a crossover cable, nothing but the attacker and the target, and it totally didn't work. You have to add devices to a wired network for this to work. On a wireless network, we were able to make it freeze the iPad 3 more or less. The iPad mini is the most vulnerable version. That will even crash completely sometimes, but mostly it just uses up all the CPU and it's not too dramatic. But if you add a second wireless device to the network, it waters down the attack and it stops hurting it. So you need, I don't know why, but that's the truth. Yeah, that's right. You got to have a fast network, 802.11n at 5 gigahertz, and you can burden the iPad 3 and the mini iPad heavily, although you cannot crash them reliably like this. So I don't know if this could possibly be exploitable. I kind of doubt it, but maybe there's some kind of buffer overflowing. Why would it crash? I can see how it would get busy and stop responding, but why would it crash, like Windows 8? Anyway, any other questions? Yeah? What's that? No, that would be wonderful. So you use a kernel debugger on the Windows machine, that would be great, although it's going to die during the attack. And I'm not competent to do that. I would love to partner with somebody that is competent to do that and figure out why this thing is really crashing. Or, you know, I put up the videos and the instructions so you can set it up. It's getting kind of expensive right now. So far we need a $600 switch to do this reliably. Although Windows 8 is a pushover. You can kill Windows 8 with almost anything. You can use cheap switch for that. It's killing the Mac that's hard. For that you need the $600 switch so far. Yeah?
On the CCSF story,
Yeah.
do you know if the reporter ever did any fact checking before she said all these things?
Well, yeah, see, this is a good question. He said, did the reporters do any fact checking on that CCSF thing? And they didn't, of course. And I tried to contact them and they wouldn't even talk to me because the CTO told them that I was unqualified and incompetent and I was part of the conspiracy. That's why I got the t-shirt. So the reporters don't seem to care. No one wants to print a retraction. I finally wrote an article for 2600 about it because I kind of would like to have some print record because I know in a few years I'm going to see this in textbooks as an example of a virus infection because the only thing the print record shows is it's all true. And then eventually 6 months later the CTO is fired for no apparent reason. So the truth just can't get out there. Nobody cares. It's kind of irritating, but I tell security conferences about it anyway. All right, well I guess I ought to get out of room for the next speaker. Oh, there's one way back there. What's up?
I think the reason why this is happening, why it's a full crash, is because the kernel stuff happens in kernel. So everything is protocol, network protocol related, and the network drivers are all in kernel. So you can exhaust the kernel memory or the kernel resources that's going to hard lock the machine.
Well, he says that this addressing happens in the kernel, and when you exhaust the kernel resources, you expect Windows 8 to go down. But why doesn't it control that? I mean, why would it let it just use up everything and crash? Why doesn't it just have some kind of signal saying I'm full, put everything on a queue or something? That's what I don't get. I can see being busy. What's that? Memory allocation in the kernel can't do that?